Hi, my name is Miss Lynch, and welcome to Inside the Classroom. I teach 6th grade math, and today our lesson is going to be on adding positive and negative integers. Today we're going to work on adding positive and negative integers. And I have a number line up here. I have cubes on the desk because these are two different strategies I'm going to work on. Everyone take your horizontal number line and put it inside your communicator. Yes?
This side.
Oh, here, I'll give you one. It doesn't, please don't put it on the side where your name is. So when you put it in your communicator, your name should still be visible on the other side.
Yep.
Yeah. So while we're going through this lesson, I'm going to ask for volunteers to come up and be a human number line. And over the next couple of lessons, if you don't have a chance to come up here today, you will have a chance in the next couple of days to come up here. So I'm going to be showing you basically two different strategies. The strategy where you're moving is where you're going to be using the number line. So we're going to be doing that. So first we're going to start with so we're going to be adding positive and negative integers. And this is what we're going to be doing today. Positive plus positive. Then we're going to work on negative plus negative. Then we're going to work on positive plus negative and negative plus positive. And remember, your goal is to try to figure out what is the pattern that I see and how can I use that pattern so that I can do numbers that are larger than 10 cubes of each color. So to begin with, I just want to start with the cubes. So the cubes, the red, no, I'm going to put the black over here. The black is going to represent positive. And the red is going to represent negative. And remember, on a number line, as I move to the right, my numbers get larger, right? And as I move to the left, my numbers get smaller. Remember earlier in the year when we actually worked on number lines? Well, now we're going to take the number line and we're going to use it to help us learn how to add positive and negative integers. So the reason why red is negative, I just want to give you a little bit of background. In business, red always represents losing money and black always represents gaining money. So you know how the Friday after Thanksgiving is called Black Friday?
Yeah.
The reason why that's called Black Friday is traditionally retail businesses, that's like all the stores in the mall and all that, retail businesses always lost money all the way up until that day after Thanksgiving. And that was the day when they turned a profit. So retailers weren't worried about losing money all year because they knew that they were going to turn a profit on that day. That's no longer true. Now retailers want to make money every single month. So black has always, in business, black has always represented positive. That's a good thing. Red has always represented I'm losing money or I'm bleeding. And what color is blood?
Red.
So if you're bleeding, if you hear that on the news about a business bleeding money, it means that they're losing and they're probably going to close soon. So I just wanted to give you a little bit of background so that you know why I'm using black and red. So do I need to spend any time on this one?
No.
Positive plus positive. Why not? Because you've been doing this since which grade? First. So if I add a positive number and I add another positive number, I'm always going to get what kind of number is positive. What did you just say, Cameron?
Well, I said a whole number.
What did you say? Why is what a whole number?
Mine said that it was a whole number.
Well, I'm only working on integers. So integers are the set of whole numbers, their opposites, and what? What's right in the middle of your number line?
Zero.
Zero. So remember, because 0 isn't an integer. 0 is an integer. We have positive integers, their opposites, which are negative, and 0, and that's the set of integers. So, and today I'm only going to work on integers. And in 6th grade, we mostly just work on integers. When you come in 7th grade, the very first thing you do in 7th grade is you review this, because in the 2nd week of school, you're working on positive and negative fractions and decimals. So, remember, this is the introduction year to positive and negative integers, and that's where we're eventually going to be able to get. Here's what I have to say to you about the 7th grade. Some of you are going to struggle with positive and negative integers throughout the course of this year. But you know what? You're going to let it sit over in your brain over the summer, and when you come back, you're going to be really good at it. All the 7th grade that I teach this year, with the exception of 1 or 2 students who I don't really think try that hard, have mastered adding and subtracting positive and negative integers. But I'm only working on adding today. So the second thing I'm going to work on is adding 2 negative integers. So if I ask you something about negative integers, that's the red cubes. So this, if I put this problem up on the board, this says take 4 reds. So can you take 4 reds? You're going to use your communicator as your work pile. So take 4 of your reds. They don't need to remain in the stack. They can be loose. So I'm going to take 4 reds, because that's what this says. This says take 4 reds. And this says add 3 more reds to it. So then this says 3 reds. So your work pile is on your communicator. So if you could put your communicator, and then the ones that aren't part of this problem, leave off your communicator. So your communicator should have 4 reds. You're going to take 4 reds, and then you're going to move 3 more reds onto your communicator. How many do you have?
4.
And what color are they?
Red.
And what do we say that represents? What kind of a number?
Negative.
So this is going to be -7. So the rules of algebra actually say when I add a negative, I put parentheses around that negative just to keep it organized. Because let me show you this. If I had this, you might think -4 plus, no, subtract 3, what? It looks confusing, right? Because it really looks like I have 2 operations right next to each other. So the rules of algebra say whenever I have negatives, I put parentheses around it. I don't when I start out, but if I have it so that it would almost look like there's 2 operations, the rules of algebra tell me I need to put parentheses around there, and then it's easier to read because it's more organized. Okay, so we had -4 plus -3 equals -7. Try this one. -5 plus -4. Yep, you don't need to, you can keep them stacked, but you don't really necessarily have to. If you have them loose like Carlos does over there, that works just as well. Or Angel has his loose over there. So if I take 1 set of reds and I add another set of reds, what is my answer?
-8.
What? -9. -9. If I want to do this on the number line, move your cubes off the number line. Do I have a volunteer that wants to come up on the number line? Michael? So you're always going to start at 0. Everybody take your number line that's on your communicator and put your marker on 0. Negative says, and you're always going to face this direction. You're always going to face the positive direction. Right here. You're right on 0. Now, for some of you, it's going to be a little more difficult because your feet are larger. Yep, you're going to face this direction. Positive says walk forward. Negative says walk backwards. So this says walk backwards 5. Could you walk backwards 5? And you're at -5. Or you can start right where this is. This says add and go backwards another
4.
4. Could you go back another 4?
1, 2, 3, 4.
And where did you end up?
9.
Negative 9. Thank you. So on your number line, this is what I want you to do. On your number line. Start at 0. And you're going to go 5. 1, 2, 3, 4, 5. Remember earlier in the year when we were doing this, we were jumping on the number line?
Yeah.
Then I'm going to go backwards, because remember, I'm going in this direction. Then this says go backwards another 4. Where did you end up? Then you went this way, because you were really going backwards. When I'm doing this, I want to do this today because when we're subtracting, it's really important that you understand positive says go forward, negative says go backwards. Or when I'm adding when they're different signs. So on your number line, go back and try that one on your number line. So I start on the number line, right? And I can start at negative 4 and then I'm going to jump negative 3 and I get negative 7. Try one more. Negative 5 plus negative 1. Nope, this is negative 9. If I were to add 4 plus 3, what would I get?
7.
If I were to add 5 plus 4, what would I get? If I were to add 5 plus 1, I get 6. So these are, what signs are these? Positive. Positive, positive equals positive. Positive, positive equals positive. Positive, positive equals positive when I'm adding. Right? We already knew that before we even came in here today.
Yeah.
The goal is that by the time you leave today, I haven't confused you where you don't even know positive plus positive equals positive, because I may go back and ask you that. And then I'll know that I've just confused you and I need to get that right thinking back in your head. Because you knew this before you came in here.
Yep.
This is a new concept for all of you. So you really got to put those thinking caps on. This is a negative plus a negative equals a
Negative.
negative
Plus negative.
equals
Negative.
negative plus
Negative.
equals negative. So when you're adding integers with the same sign, just add and keep the sign the same. So positive plus positive equals positive. Negative plus negative equals negative. Okay, so now we're going to work where one is positive and one is negative. So if I say negative 5 plus 2, that's take 5 reds out and put it on your communicator. Take 5 reds out and put it on your communicator. Cameron, take 5 reds out and put it on your communicator. So this says take 5 reds and what are you adding to it?
2 blacks. 2 blacks.
Let me just backtrack a little bit. What is this value? And I'm going back to when we were doing algebra, when I have 1 black and 1 red.
A 0.
0, because what is this called? A 0? A 0? A 0 pair? A 0 pair? So if I have, do you have any 0 pairs on your board that you can clear? This is 2 black.
Yeah.
So you have a picture right here of 5 reds and 2 blacks. And a 0 pair consists of what? 1 positive and 1 negative? Do you have any 0 pairs you can clear off your board?
2.
Okay, clear them off. So I'm going to do that here. I'm clearing that off because that equals 0, right? Zachariah just told us that equals 0. And I end up with
-3.
3 reds, and we say that's -3. Someone want to come up here and do it on the number line? Angel? So I'm going to start at 0. I'm going to go backwards 5.
Oh, I know how you did that.
And now I'm going to go forward 2 times. And you're going to end up at, what are you going to end up at? -3. The larger your feet are, the harder this is. But this is so that, I did this so that every spot is even, because if you look at the tiles on the floor, that's why. That's where it is. Because if I tried to do it myself, it's not going to be even, or I'm going to take a ruler and it's not going to be even. So these are 9 by 9 squares. So if your foot is probably bigger than a 7, like mine doesn't really fit in there exactly right, but it's good enough. Because you can kind of, you can either, you want to make sure you're facing forward, and if it says negative, you're going backwards. If it says positive, you're going forwards. So we know that -5 plus 2 is -3. Okay, so try this one.
That's it.
5 plus -8. Rowdy, do you want to come up and do this on the number line? So remember, you're going to start at 0. Very good. 0 is right here. Oh, all right. If you double check on your number line and see if you get the same answer. I don't think that's what you got. So this says go forward 5. And this says go backwards 8.
8. 1, 2, 3, 4.
Where'd you end up?
-3.
Is he correct?
Yep.
-3.
Oh, okay.
And the same thing, if I could draw a picture of this. Is it the same thing?
No.
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 Why is positive and negative not the same thing? Because they're on different sides of, they're on different sides of the 0, right? To the right is positive and to the left is negative. Then I'm going to, I can do this. And I know my answer, this is good, my answer is going to be whatever I'm left with. So one of the strategies we're using today is the cubes, because it's really going to help you visualize. I'm showing you on the board how if you don't have the cubes, you could draw a picture. You only need 2 crayons, right? Or 2 different colored, a red pen and a black pen, or a red pen and a blue pen, or a pencil and a pen. You just need 2 different things in order for you to be able to visualize this. And because it's a brand new concept, you really do need to work a lot of time on the visualization. I don't know why you're touching the cubes. Could you please put them down unless you're using them? So now we have 5 plus, let's go back to my summary board. Because now I have 5 plus -8 equals -3. And I'm going to have you try this one. -2 plus 5. Very good. Use the cubes if you need to use the cubes. Use the number line if you need to use the number line. Use mental math if you already think that you're there. But we're not all going to be that same strategy at the same time. Did you get an answer, Nathaniel? Nathaniel, come up on the number line. Start at 0. What does this tell you to do?
Go back to.
Go back to. What does this tell you to do?
Go up 5.
Please do that. What's your answer?
+3.
+3. Oh, I like how he even said positive. What was that? -2 plus 5. Thank you. Okay, so look at the board. So let's look at the board. -5 plus 2 is -3. Negative 3 plus 7 is 4. 5 plus negative 8 is negative 3. I don't know why I ended up with so many negative 3s and 3s. I didn't do that on purpose. Negative 2 plus 5 is 3. So, actually I want to change this to say 5 plus negative 2. Could you guys quickly tell me, is that going to be the same answer?
Yeah. No.
Could you do that? 5 plus negative 2.
3.
Yes, it is?
Yeah.
Because the commutative property of addition says order doesn't matter, right? So, sometimes I start with a negative and I end up with a negative. Sometimes I start with a negative and I end up with a positive. Sometimes I start with a positive and I end up with a negative. Everybody should be looking at the board. Sometimes I start with a positive and I end up with a positive. So what I start with mustn't have anything to do with the rule. So I want you to think about what you did and how you know what the sign of your answer is. So I want you to turn and talk to the person next to you. Don't forget to include Zachariah. What do you think? What are you really doing when your signs are different and it tells you to add? All right, let's regroup. I heard some really good thinking there, because remember, most of you, who in here has done this before? Okay, so were you, what? Oh, okay. So for most of you, this is the first year you've even practiced it, right? So Rowdy, what did you guys say you're really doing when you're adding and the signs are different?
Subtracting.
You're really subtracting. Johnny, didn't you say the same thing? You're really subtracting. How do you know, because 5 minus 2 is 3, right?
Yes.
And 7 minus 3 is 4, and 8 minus 5 is 3, and 5 minus 2 is 3. How do you know whether your answer is going to be positive or negative? Zachariah?
You know if your answer is going to be positive, negative, if not a number can cancel out each other. If you got either more positive or negative.
If you have more positive or negative. I really like how your wording is, because in the other class they tried to say whichever number is larger. But isn't positive numbers always larger than negative numbers?
Yes.
So by using the cubes, it's easy to visualize whichever one I have more of, which is actually called, who remembers the distance away from 0 is called what?
Absolute value.
Absolute value. So instead of saying whichever one I have more of, track the speaker. Whichever one I have more of, I could say whichever one has the higher absolute value. Because in negative 5 and 2, which one has the highest absolute value, meaning which one is further away from 0?
Negative 5.
That my answer ends up being negative. Nicholas, in negative 3 and 7, which one has the higher absolute value, meaning which one of those is further away from 0?
7.
Please don't answer for another student. And 7 is positive, my answer ends up being positive. Alex, in 5 and negative 8, which one has the higher absolute value? Meaning which one is further away from 0? Negative 8, my answer ends up being negative. Xavier, in 5 and negative 2, which one has the higher absolute value? 5, and which is positive, and that's why my answer ends up being positive. So I need to think about that. When the rule says add, but my signs are different, I'm really doing what, class?
Subtract.
I'm really subtracting. Remember, if the signs are the same and it tells me to add, I'm really adding. This is where the confusion kind of lies with a lot of people. Your brain says you want to add, but if you ignore the signs, you know you're going to get your answers wrong. So when adding integers with different signs, meaning one is positive and the other is negative, subtract and keep the sign of the, I know that's a lot, and keep the sign of the integer with the larger absolute value, and I'm just reminding you what that means, the distance away from 0, and remember distance is always positive. Thanks for joining us inside the classroom, learning how to add positive and negative integers. I hope you learned something today. Thank you.